This is the new playlist in our channel, that is image processing. Okay, let's see this image processing by unit wise. This is a unit 1 syllabus of image processing, that is digital image fundamentals, digital image through scanner, digital camera, concept of gray levels to binary image conversion, sampling and quantization, relationship between pixels, imaging geometry, 2D transformations, DFT, DCT, KLT, and SPD. Okay, this is the concepts in Unit 1. Let's see one by one concept in each video. Don't skip any video. See from the starting video. Okay, let's see here. Firstly, we should know what is digital image. We are continuously talking about the digital image fundamentals and digital image through scanner and digital camera. So what is meant by digital image here? What is digital image processing? Digital image processing is a method to perform some operations on an image. To perform any operation on any particular image, this digital image processing is used. This is a method. In order to get an enhanced image or to extract some useful information from it, we use this digital image processing. It is a type of signal processing in which the input is an image and the output may be image or characteristics or features associated with that image. It is a type of a signal processing in which we are going to give an input in the form of what? Image. In the form of image, we are going to give an input and the output may be again that image or else our characteristics features associated with that image. Okay. And we can also say it as digital image processing is defined as the process of analyzing and manipulating images using computer. Generally, we use our computer. So, by using our computer, we are going to manipulating or we are going to process of analyze the digital images. Okay. The main advantages of DIP, that is digital image processing, is it allows wide range of algorithms to be applied to the input data and it avoids noise and signals distortion problems. That means we are going to avoid everything and we are going to produce a clean and neat picture where there is no noise and there is no problems. Okay, this is called digital image. Next is fundamentals of digital imaging. This question they may ask for 10 marks directly, so I'm going to explain it clearly. Don't feel that it is lengthy. If you write it on this paper, it will be very short and clear to understand. Okay, let's see what is here fundamentals of digital imaging. Here we have firstly image acquisition, image enhancement, image restoration, morphological processing, segmentation, object recognition, representation and description, image compression, color image processing. Okay, these are the fundamentals of digital imaging. Let's see here one by one. First one is image acquisition. That is nothing but it is a process of acquiring. It is the process of acquiring or getting an image. In this image acquisition, we are going to process means we are acquiring or getting an image from any source. From any source, we are going to getting an image. The entire processing has been done on images. This image processing is entirely going to be performed on a image. Okay. The entire processing has been done on images so that the images are first needed to be loaded to the digital computer. Firstly, if you want to perform any action on your particular image, what you'll do, firstly, you have to uh, keep it in your computer, that image, which image you want to modify, that image should be in your computer. Then only you can modify in your computer. That is the sense here. Image acquisition is nothing but we are going to getting an image from any source or we are going to edit an image. To edit an image, we need an image. So we are keeping that image in our computer. How we are going to keep it to the loaded to the digital computer? That is nothing but digital cameras, scanners, etc. Okay. Next, after image acquisition, image enhancement. We are going to enhance that image. That is, Image enhancement techniques have been widely used in many applications of image processing. Okay, this image enhancement may have we can use widely used in many applications of image processing, where the subjective quality of image is more important for human interpretation. Let's see here, we are going to gather an image into our computer. So we are going to enhance that image. We have several methods to enhance that image based on either spatial or frequency domain techniques. Okay, some examples of image enhancement techniques are here: point operations, spatial operations, transform operations, and pseudo coloring. Okay, we are going to do this all the image enhancement techniques to enhance our image. Okay, first we are in image acquisition, we are going to acquire an image, and in image enhancement, we are going to enhance by using some techniques. And in next, here, image restoration. Nothing but in many applications, like we have our old memory photos. Okay, in that photos we cannot see the image clearly. So in many applications, for example, satellite imaging, medical imaging, astronomical imaging, poor quality family portraits. So these are all the images we are cannot see that images clearly, right? So by using this image restoration, we can see that clear image. The imaging system introduces a slight distortion. Often, images are slightly blurred, and image restoration aims at de-blurring the image. Remember this point, de-blurring the image. That means we are going to produce a clear image rather than the previous image. However, image enhancement, which is subjective, image restoration is objective. Okay, that is a subjective. Whereas image enhancement, we are going to adding a few colors, or we are going to enhance the picture. But in this image restoration is an objective. That means in the sense that restoration techniques tended to be based on mathematical or probabilistic models of image degradation. Okay, don't be confused. This in this image restoration, we are going to make an old picture into new one. Whereas in image enhancement, we are giving some colors, or we are adding some colors to the image. Next, morphological processing. This morphological processing is a tool for extracting image components that are useful in representation and description of shape. That means extracting and describing image component regions. Generally, we use our mobile phone, whereas in the mobile phone, we will keep our fingerprint to unlock our device. So in that case, what we are doing, we are going to extract, we are going to giving our fingerprint to the mobile device, so that mobile device may understand that the fingerprint belongs to us or not. So here also, that mobile device can also understand which finger it is. It means for the left hand side or right hand. Okay. Same here, morphological processing is a tool for extracting image components that are useful in representation. We are going to represent our image. Okay, this is called as a morphological processing. Next, image segmentation. Image segmentation means segmentation is a process of partitioning a digital image into multiple segments. We can create from the digital image to a multiple segments. The goal of segmentation is to simplify and or change the representation of an image into something that is more meaningful and easy to analyze. That means producing an actual image can be difficult to understand what is it. So we are going to image segment. We are going to segment this image in the process of here in the picture. See here, this is the original image, and its right side we have some their digital images are produced into multiple segments. We can see it clearly how it is, how they are seeing and how they are laughing, and what is the facial expressions of them can be clearly estimated in the multiple segments. So the goal of segmentation is to simplify and or change the representation of image into something that is more meaningful and easier to understand. Okay. Basically, we have here threshold-based segmentation, edge-based segmentation, region-based segmentation, clustering techniques, and matching. Okay, these are the image segmentation techniques. And the next one is representation and description. After finding all the things, we are going to represent and description. Okay. This representation deals with the compaction of segmented data into representation that facilitate the competition of descriptors. It means we are going to represent the picture after performing those all the actions. Okay. Description deals with extracting attributes that result in some quantitative information of interest or basic for differentiating one class of objects from other. Okay. We are going to represent and we are going to description. We are going to give the description about that particular image. And next, object recognition. You already know about object recognition. That is, we are going to recognize by using any label to it, by giving any label to the particular image. Object recognition is a process that assigns a label to an object based on its descriptors. Based on its description, we are going to give a label to a particular image. That is called as object recognition. Next, image compression. You all know image compression when we are going to apply any particular Google Forms. They'll ask that to compress the image into some 50 KB or 100 KB, right? So that is the reason we are using this image compression. We are going to compress the original image, but we are going to compress the size of the image. We are not going to cut the image. We are going to compress the image. That means image compression is a technique used for reducing the storage required to store or save an image. To store the same picture, but with a storage quantity is less. Okay, that is, for in that case we are using this image compression or the bandwidth required to transmit an image. Image compression algorithms are basically classified into lossy compression and lossless compression. Okay, let's see here. Lossy compression is nothing but loss of information present in the image during compression. We may lose some information present in the image during compression is called as lossy compression. Whereas lossless compression means no loss of information present in the image during the compression. See in the image down here, we have this image size is 5.7 MB. We have compressed that original image as it is into 470 KB. Whereas we doesn't have any changes. We doesn't lose anything from the original image to compressed image. So this is called as lossless compression. If we lose any information about that particular image, then we'll call as lossy compression. Okay. Image compression algorithms may take advantage of visual perspection and the statistical properties of image data to provide superior results compared with generic compression methods. Okay, this is called image compression. And the next color image processing. Color image processing in the sense we are going to add the colors. Color image processing is an area that has been gaining in importance because of the significant increase in the use of digital images over the India. Nowadays, we are going to use only a particular images which is very colorful and HD images. We are not going to consider the black and white images, right? So in that case, we are going to color the image processing. We are going to give a colors. We are going to add the use of color image processing is motivated by two principal factors. Why this color image processing is motivated? Because of two principal factors. That is, first one, color is a powerful descriptor that often simplifies object identification and extraction from a scene. When we add a color to the particular image, it will gives an object identification. We can identify which image is this. Okay. Next, what is the second principle? Human can distinguish thousands of color shades and intensities compared to about only 2 dozen shades of gray. Okay, based on the human and for the colorful descriptors, we use this color image processing. Okay, thank you.